In this lesson, we're going to begin our unit on statistics. We're going to focus on populations and sampling in this lesson. A sample is a subset of an entire group. So if you're looking at like maybe the whole school, you wouldn't ask the whole school a survey. You could get a sample of it, so part of the school. So it would be a subset of the whole school. It refers to a portion of the group with specific characteristics. Data collected from the sample is called a sample statistic. So another example would be vowels are a subset of the alphabet. So vowels don't represent the whole alphabet, but it represents a group of letters within the alphabet. A population is when collecting the data, the population references the entire group. So a population is the entire group. A sample is just a part of that population. Data collected from the entire population is called a population statistic. So the alphabet is the equivalent to a population because it's the entire alphabet, while the consonants are your sample because it's just a part of the alphabet. So let's look at some statements. So we're going to start by looking at some population statements. And then we're going to determine if it says the following statements are populations and determine a possible sample that is part of the population. So these statements that we're going to be writing aren't the only answers that it could be. So if our population is people living in a specific neighborhood, a sample, and I'm going to write a couple, one sample could be the elderly people. So from the entire neighborhood, you're elderly people. Another sample might be the toddlers in the neighborhood. See if you can come up with a third example of a sample. Another population would be families with children. A sample could be families with one child. Or you could have families with twins. See if you can come up with a third example of a sample from families with children. Another population is seniors at East High School. So a sample of this could be senior girls. So from all of the seniors that are graduating, just the girls. Or you could have seniors that drive to school. So from all your seniors, just the ones that drive to school. See if you can come up with a third example of a sample from the seniors at East High School. Now let's do the opposite. We're going to look at some sample statements and then come up with some possible populations. So again, this isn't going to be necessarily the only answer. So if you have children who play football for the YMCA, the population could be people who participate in YMCA programs. So a much broader category or a bigger category than just football. So we went from just football to a bigger category of all of the programs. Number 5, students who were on the B honor roll for the first 9 weeks. So a population, we could say all students enrolled during the first 9 weeks. So that would include every student, even the ones not on the B honor roll. And then we get smaller and have a sample of those just on the B honor roll. Highlight number 6 and then see if you can come up with a possible population for that sample. Now, the next thing we want to talk about is what is a statistical question? A statistical question is one that can be answered with data that varies. The answer to a statistical question must be different. So we're going to look at this graphic organizer that gives us a statistical question, and then we want to be able to answer it. So our first statistical question is, what do 7th grade students want to do for the fall festival? So the first thing we want to think about is, how could we collect this data? One way that we could collect the data is to survey 7th graders at lunch. The next thing we want to think about is the data a population or a sample statistic. So this, if we surveyed 7th graders at lunch, this would be just a sample. So you're not going to get all of the 7th graders. Next, why? Why is this just a sample statistics? Because not every student will be asked. You may have students who don't eat lunch. You may have students who are absent that day. So you're not going to get all of your 7th grade students. The second statistical question is, what is the average grade on the semester exam in Miss Johnson's class? So first, how can you collect this data? Well, you can use the scores recorded in her grade book. So you wouldn't have to necessarily go around and ask everybody what they scored. You can just look at the grades that she wrote down. Would this be a sample or a population? This would be a population, because it's going to represent the whole class. And then why? Because it's an average of the pieces of data. Because it is an average, all of the pieces of data would be included. So the whole class would be included, because everybody is going to take the exam. Go ahead and highlight those next 2 rows, and then you can come back to those and answer those on your own. So let's get a little bit more in depth. So when we talk about a population, remember, a population is an entire group. And that could be an entire group of people. It could be an entire group of an object or a subject. So an example could be the students at PCA. That's our entire population. We're not looking at a specific grade level or a specific campus. We're looking at the entire group of students at PCA. Then remember, a sample is a part or a subgroup of the population. So for example, Miss Barger's math classes. So it's not the whole PCA student body, it's just the ones in Miss Barger's math classes. So some other words that we're going to talk about are unbiased sample and biased sample. So an unbiased sample is a representative of the larger population. It is selected at random. And it's going to be large enough to provide accurate data. Because if you don't have a large enough sample, you're not going to really get the best data to make decisions off of. So if you're trying to figure out what type of ice cream to buy everyone, and there's 50 people, and you only ask 2 of those people, those 2 people might like the weirdest flavors. So you want to make sure that you have a large enough sample to get an accurate picture of your data. Now, a biased sample is going to be a sample that is not representative of the larger population. And it usually favors a certain group. So you might pick, say you want a particular brand of ice cream, you might pick the people you know that are going to pick that same one also. So let's look at some examples of deciding if it's biased or unbiased. Number 1, Casey surveyed the members of his soccer team to ask them what their favorite sport is. This is biased. He's asking his soccer team. So clearly, their favorite sport is going to be soccer. It might not 100% be soccer, but since you're asking the soccer team, that's probably going to be their answer. Number 2, an airline is conducting a survey to determine whether people prefer to check their luggage or carry it on. They ask every 10th person that walks into the airport. This is going to be unbiased. They didn't choose specifically who they were asking for. They randomly chose the people. They didn't know what the 10th person coming in was going to be or what the 20th person was going to be. So that was random. They didn't know who that person would specifically be. Go ahead and highlight number 3 and 4. And again, you're going to tell me if it's biased or unbiased, and then just a short little sentence or a couple words why you chose that. Now, one thing we can do with our samplings of statistical data is we can make predictions. The results of an unbiased sample are going to be proportional to the results of the population. You can use an unbiased sample to make predictions about the whole population. A biased sample is not going to be good for making a prediction. So you only want to make predictions based off of unbiased samples. So number 5 says Green Valley Middle School conducted a survey of 125 random students, asking them how much time they spent each night on homework. The results are shown over here to the left. So 4 people spent up to 30 minutes on homework. 64 people spent anywhere from 30 to 60 minutes, and so on. So you can tell a good number of students were surveyed. 4 plus 64 plus 25 plus 32 is your total number of students surveyed, which the problem told us was 125, and they were random. So it's a good number of students, and they were chosen at random, which makes this unbiased. What percent of students spend no more than 30 minutes on homework? So that means the most they spent was 30 minutes. It was 4 people, but it wants to know what percent. So that would be 4 out of 125 students. And 4 divided by 125, and we can put that in the calculator, is 0.032. Again, it asks for the percent. So we need to move that decimal 2 places to get 3.2%. So not a big percentage of the population would spend less than 30 minutes on their homework. B wants to know what percent of the students spend at least 31 minutes on homework each night. So at least 30 minutes means more than 30. So more than 30 is going to be 64 plus 25 plus 32. So if we add that together in our calculator, we get 121 out of the total 125 students. 121 divided by 125 in the calculator gives me 0.968. But again, we want the percent, so we want to move our decimal 2 places, which would give us 96.8%. C asks, if there are 1,200 students in the school, approximately how many students would you expect to spend more than 1 hour on homework? So first we need to find the percentage that would be. So just like we did, spending more than an hour. So more than an hour is going to be the 25 plus 32. 25 plus 32 is 57 out of the 125. So we're finding that percentage of just the sample. So that's 0.456, which equals 45.6%. Then we want to know what that is out of 1,200 students. So we're going to multiply 45.6% times 1,200. And that would give us the 547 students. So we took our sample, we found that percentage, and then applied it to the whole population. And we could do that because it was an unbiased survey. Go ahead and highlight number 6 and do all of those parts based off of the table to the left. And then highlight number 7.